we are going to analyze this rational function by determining its asymptotes and by looking at its first derivative. So first of all, in determining its vertical asymptotes, we're going to look at values which cause us to divide by 0, but the top is non-zero. So this denominator factors into x plus 3, x minus 1, indicating that the two values which cause us to divide by 0 are going to be negative 3 and 1, and the top is non-zero. So we'll indicate vertical asymptotes. X equals negative 3, x equals 1. And again, make sure that you write down x equals negative 3 and x equals 1, not just negative 3 and 1, because you're giving the actual equation of two vertical lines. And then, for the horizontal asymptote, notice that the degree of the top is 1 and the degree of the bottom is 2. So when the degree of the denominator is greater than the degree of the numerator, it's going to have a horizontal asymptote of y equals 0. So for finding the first derivative, we use the quotient rule. The derivative is the bottom times the derivative of the top, which is 1, minus the top, which is x, and the bottom is 2x plus 2, all over the bottom squared. Now in simplifying the numerator of the first derivative, this is going to simplify into negative x squared plus 3. And the bottom is going to be factored into x plus 3 squared, x minus 1 squared. And if we do a first derivative analysis of this function, we have critical values which are going to be anywhere where the first derivative is equal to 0. There are no such values because x squared plus 3 is always positive, and therefore with the negative sign, the numerator, the entire numerator is always going to be negative. However, there are two values where you're still undefined at negative 3 and at 1. So the function is going to be actually undefined at these two values. We'll indicate undefined and undefined. However, if we look at the first derivative within these three intervals, from negative infinity to 3, negative 3 to 1, and 1 to positive infinity, the top of the first derivative is always negative. And then the bottom, the denominator, always being squared, is always going to be positive. So any value that you put into this first derivative, where that first derivative is defined, it's going to be negative over positive, which is negative. So the first derivative is negative in all three of these intervals, while still being undefined at negative 3 and 1. So in those three intervals, the function is going to be decreasing. Decreasing everywhere where the function is defined. So if we look at our final answers, we would indicate that the function is increasing nowhere. It's decreasing on the intervals from negative infinity to negative 3, negative 3 to 1, and 1 to positive infinity. You do not want to just say that it's decreasing everywhere, because of course it can't be decreasing at those two values where the function does not exist. It has no local maximum and it has no local minimum. However, it does have a horizontal asymptote of y equal to 0 and vertical asymptotes of x equals -3 and x equal to 1. And so therefore, this is the final graph of the function. Noting the asymptotes, the x-axis, y equal to 0, is also an asymptote, and the function is decreasing everywhere, and the function does cross the origin at 0, 0.